All right, the third day of this unit is going to be talking about logarithmic functions. One thing you need to remember is that exponentials and logarithmics are just inverses of each other. So like we talked about in the first lesson, their inputs and outputs just trade places. So you see here, there's b here, and b is your base, x is your input, and a is your output in the exponential function. For the logarithmic function, b is still your base, and a and x actually switch places. So your inputs and outputs switch places. So the first part of this lesson is just being able to take an exponential and rewrite it as a logarithmic. So the base of my exponential in this first example here is 3. So that means I'm going to have log base 3. The output 243 is now my input, and the input of 5 is now my output. So everything just switches places. So 25 to the 1/5 equals 5. So again, that's going to be log base 25. My input switches to 5, and the output is 1/5. To go in the other order, I have a log base 10, which means the base of my exponential will be 10. The input is now 4, and the output is 10,000. For the last one, the base of my exponential is 4, my input is x, and the output is 1024. Something you can notice, or a lot of people do, is when they're rewriting them, no matter which, if you're going from exponentials to logs or logs to exponentials, they kind of show as a circle. So you start with your base to your input to your output, your base to your input to your output. It circles around, so you write it like that. So there's two, we just have to rewrite them on your own. There are some special logs that we need to talk about. Here, this first one is just saying when the base and the input match. So notice how I have log base b, but then the input's also b. So when your base and your input match, your answer is just going to be 1. When your input is 1 in the second step, then that means the answer is 0. And then the last part, if you notice this last log, there's no base written here. It just says log 4. When there's no base, that means you have a base 10. So that's the same thing as saying having a base of 10. So if you look at the bottom, it says log is what is programmed into your calculator. So your calculator will only calculate base 10. So if I give you base 10 problems, you just plug that in the calculator and find your answer. If it's any other base, those logs have to be calculated by hand. So here are our last two examples. Again, the reminder that log base 10 is what is programmed in your calculator. So you can use your calculator for those problems. Otherwise, everything else has to be calculated by hand. The way that we calculate logs is it's actually easier to think of them as exponentials. So my first step, I'm going to take log base 10 of 0.01, and I'm going to rewrite it as an exponential. I don't know what my answer is, what my output is yet, so I'm going to put my variable there. And 0.01. This is something that no matter what your base is, the calculator can figure it out. I'm just going to keep plugging in numbers for my exponent until I know what gives me an answer of 0.01. So here, this log equals -2. So for this next example, same deal. I'm going to start with my base of 5. I don't know what the exponent is, but my answer is 1/5. So here with the calculator, I can't put log base 5 into the calculator, but I can just put 5 and try different exponents until I get 1/5. If your base ever switches from a whole number to a fraction or vice versa, that tells me my answer is going to be negative, because a negative exponent actually flips your number. So this answer is -1. So here's where you're really going to need to recognize your exponents and your exponent rules from Algebra 1. So here's your last try on your own. Good luck.